robotics and AI. So what we do primarily is that we teach people or individuals or children who are interested in programming, coding, and robotics. So we have centers around that. You can always visit. We have online sessions as well. But primarily for today, we want to talk about robotics and AI. That is building intelligent machines. I believe most of you here know what robotics is. At least you have a fair idea. That's why you're even here in the first place. Yes. And then programming, coding, there are other languages that we all have as well. We all know. So we are delving deep into combining the two and how best we can make do of all of them. So we are going to explore the innovative world of robotics and artificial intelligence as we delve into the cutting-edge technologies that are shaping the future of intelligent machines. So today's agenda is going to be the introduction. That is a comprehensive overview of the key topics to be covered in the presentation. And then 2, we'll talk about robotic basics. That is, understand the fundamental components and capabilities of modern robots. And then 3, AI concepts. Explore the core principles and applications of artificial intelligence. And then 4, integration. Discover the synergies between robotics and AI and how they can work. Along the way, if maybe you didn't get anything and you don't understand anything, feel free to ask questions. As well as you can also, we have a question and answer session too. So if you feel you can't wait and you want to ask, feel free to ask as well. Okay. So ask the question, what is a robot? So a robot is a machine capable of carrying out complex tasks automatically, sensing its environment, processing data, and acting based on what? Programming. So a robot is like a metal device or anything we see around us on daily basis. Sometimes when we talk about robots, people always think about the humanoid robots, the ones that are standing and walking, but we have a lot of robots around us that have been programmed doing our day-to-day tasks for us on daily basis that we don't even know. When we go to our homes, we have some like our microwave machines, our washing machines, our refrigerators, our television sets, the remote you use to control all of these things. They are all what types of robots that we already have running in the system already. So now, when we talk about these things, so they make things easier. They study the environment, our mobile phones, our laptops. All of these things are robots that we would use on daily basis that you may not even know that it's a robot. But you want to see something moving before. So examples of robots are what? The industrial robots. So when we talk about industrial robots, like you can see the factory hands there. So these robots are called arm robots. So these robots, ARM, these robots do welding, fabrication, putting things together. Like when you go to these big factories, like Mercedes, Toyota, Nissan, those big factories, is these arms that build most of the vehicles and most of the things that we use on large scale. The air conditioners, the refrigerators, the chipsets, the smart boards, all of these things. These kind of robots would build them so that we can get large quantities of them in a short period of time. And then we have the service. So the service type of robots are the robots that provide services for us in our homes. Like we have the washing machine, we have the refrigerators, we have the TVs. So these are the types of what that we have as well. And then we have the consumer. So the consumer types of robots are robots that provide forms of services that we use on daily basis as well. And then the educational. So the educational ones are prototypes, like the ones we have here, to help you learn about it. So prototypes mean the ones you do first, test it before you move it to the industrial level. So these are educational ones that you learn with. And then autonomous. So the autonomous are the big ones for the vehicles, the smart ones, the vehicles that are built. Those are autonomous ones. And then we have medical. So the ones that perform surgeries and other complex issues. And then we have research. So we have the ones that will go to Mars and go and explore the other planets and other things as well. And then we have AI-powered robots. So AI-powered robots is what we are coming to learn how to merge the two to perform these wonderful tasks. So now let's look at the components of a robot. So when we say a robot, every robot has main components. So first we have sensors. So I believe you all know what sensor is. I want this to be interactive as possible. So if someone can tell me what a sensor is, any volunteer, please. Sensor. If you say sensor, what do you think a sensor is? Let's make it as interactive as possible. Just sharing ideas. You don't need the exact answer. Okay.
My name is Ev. I can't define a sensor, but one of the typical example of a sensor is one we have on the phone. When we pick up our phone and we put it on our ear, there's a sensor that detects that the phone is our ear, so it should shut down the screen. So that's one of the sensors.
Okay, thank you very much. So that's a sensor. So it senses that you are on a call. So you should turn off the screen so that your chick doesn't press any other key to either drop the call or make any additional call in addition. Yes, another idea on it. Yes.
My name is Victor. So how I understand the sensor is it transforms the environment in the physical world into electric signals so the computer can understand what's going on in the physical world.
Thank you very much. So that is also correct. Any other one again? Okay, so like he said, so senses our activities. Like the way our bodies do, we know we have senses as well. I believe you know you have senses. How many senses do we have as a human? 5. Thank you very much. So we have senses. Can we have people naming them for us? Just one at a time. Yeah, one at a time, please. You have the eye. Okay.
The skin. The skin. The skin.
Any other?
The nose.
Uh-huh.
Yeah.
Yeah. Uh-huh. What else? Come again. Tongue. Okay. So we have categories, we call them. I don't know who can categorize them for me. Categories. There are categories, we give them. Yes. Our students. Can you help us? Uh-huh.
Sense organ.
So name the sense organs for us. So we have the smell, the taste, the feel. These are some of them. So when it comes to taste, that's where the tongue comes in play. When it comes to hearing, that's where the ear comes in place. When it comes to feel, that's where the skin comes in place. Are you following? Yes, so the robot has some of these things as well. So a picture of them is what you see there. And then we have the prototypes of them. So when you're doing robotics, these are what you use as sensors. So we have IR sensors, we have the touch sensor, the infrared sensor, and stuff like that. So there are a lot of sensors based on what you are doing. So the sensors will detect what we call edge avoidance, obstacle avoidance, touch, feel, hearing, speaking. All of these are sensors that are built into the robot to become smart. So as you can see in the pictures, these are how they look like when you're in the robot, and these are prototypes for building our prototypes robot for what testing. So these are examples of them. Okay, and then we have actuators. So actuators are also another component of the robot. What an actuator does is that it makes moving what's possible. So an actuator is in a what we call a motor. So the motor is what drives the robot to move. If you get it. So when you have a motor, when you have a robot, for instance, what we have here, this here is what we call the motor. So this motor drives the wheel to move. So there's an actuator in this particular thing that helps the motor to move. By the power it draws from the battery, it helps the robot to move. So we have vehicles that have actuators to help the vehicle move. So anything that is movable or is able to accomplish any task from moving from one place to the other has an actuator in this that help it to move. And then we have control systems. So control systems, basically what they do is that depending on the particular task of the robot, what we'll do, you align it to it. Okay, move from this direction to that direction. Then it's able to move. move from here to here, then it's able to move. So that's our what control systems. So depending on the particular what use of it, we have robots that does particular tasks, like the ones we have in our homes. We have other ones that are general. So depending on what it's supposed to do, it's able to what help itself. And then we have power supply. So without power supply, our robots cannot what work or perform their task. So it's either it's connected to main electricity grid or a battery power, any of them. So battery power, that means needs to charge. Like our phones, you charge our phones to have enough battery power in order to what to use them. And then if it's the main grid, to plug them, like our TV sets, our washing machines, our microwaves, we plug them in order for them to work as well. So these are the main components of the robot, the sensors, the actuators, the control systems, and the power supply. Before we move on, please, any question on robotics? Yeah, moving on to the next one. Any question on robotics? Yes.
You mentioned you have services and products of robotics. What products have you built that is currently in the market?
Okay, so our devices here are all prototypes. So what we do is that we get innovative ideas, we build. As of now, we are still working on it. We don't have anything currently on the market, but we have things that are already there, like LPG detectors and drones, high washing drones that are able to go high to wash high rising buildings. All of these things are there, but they're not really on the market like you know it's for sale. But there are prototypes that we are hoping that it will break the market. Yes. Please, any other question again?
Please, what's the difference between a computer and a robot in terms of engaging in with the physical world and processing information?
Okay, so I would say a computer is a kind of robot, but it does a specific thing. So what do we use the computer for? When you take a laptop, for instance, use it for your basic works. You can use it for coding as well. So it performs a specific task. So every robot and what it does. So we don't have a general robot that is able to do everything. Every robot is assigned to do a particular thing. So no matter how smart the robot is, it cannot do everything altogether. We need specification. You can have a robot that will do cooling, will do microwaving, will do heating, will do like laptoping for you, will do everything for you at the same time. You get it? Yes. So it's a type of robot. Okay. Any other question again, please? All right, so let's move on. So what we are moving on to is what's introduction to what artificial intelligence. Artificial intelligence. So now, what is artificial intelligence? Popularly now known as AI. AI. Okay, so a field of computer science focused on creating systems and machines capable of performing tasks that typically require human intelligence. So these things, like we said, it's a field of computer studies. So they create systems and machines that is able to performs human tasks. So certain things that under normal circumstances you will have thought to do or suffered to do. Now we have systems and programs that are able to read and perform these tasks for you to make it easier. So then you will not have to go through the normal struggle of doing a whole lot of research again to come out with an outcome. These things are able to scan. If you are looking for a particular information or research, they're able to scan thousands of websites all over the world to get your information for you as quick as possible. You will not have to go to libraries, climbing shelves, looking for books. And then after Google came with an easier one where you type, now you just type your question, it scans across websites all over, libraries all over the world, and brings you your answers. So some of these are some of the works of artificial intelligence. We also have some on our phone that are able to help us. Now, as first, you have to take your phone and then type a password before it opens. Now, you just look at it, it opens, and then you start working. So these things are there to make our life easier. And people feel that these things will take over, and then we are not going to be there anymore. It's the same thing that happened when ATM machines started. Those working in the banks thought that their works are going to be taken away from them. Now, the ATM machine is going to dispense cash, it's going to do this, so we will not get work to do again. If you go to the banks, don't you see tellers there? You will still see them around. So there are no innovation is going to take away anybody's work. It's just going to help. Now, instead of me going to the back teller and then forming a long queue, stressing the teller. You get there and then I'm doing a withdrawal of 100 cedis, 200 cedis. You can just go to the ATM machine, take your 200, 300 cedis, and then large sums can go to the counter. It makes life easier for everybody. So please, the fear of AI taking over systems and jobs, take it away from your mind. It's not possible. It's just helping you to make your life easier. All right. So we have key components of AI, just as we had for robots. So key components for AI are machine learning. So when we say machine learning, it's the capability of a device to learn its environment, to be able to adapt to it. So it adapts to the environment and it's able to perform additional tasks to it. So it's able to sense, okay, let's say you have an AI robot that is able to move to sweep. If there are obstacles with time, it's able to learn that when I move in this direction, maybe 5 centimeters, there's an obstacle. So let me just turn automatically. This is adaptability. We have vehicles that are also able to detect obstacles that are ahead of you and then alert you. So all of these are machine learning. So gone are the days when we have machines that we spoke about. That's only one thing. But now we are moving to another one that this time the machine gathers data and then works with it. So it just doesn't give you just don't tell the machine what to do now. Now the machine is able, you tell the machine what to do. With the help of AI, the machine is able to gather more information, gather more data, get to know you well, and then like what we have nowadays, algorithms. When you browse, you visit one website, a particular hair product or something, the next minute you start getting adverts on hair products for sale. You go to a mechanical website to search for some device. The next time you see adverts coming, so you notice that the adverts are coming on your phones are things that you need. If you are not into real estate, they will not bring you adverts of certain things. If you are not, so male and female, you see that the adverts are always different on the phones because they know that, okay, this is a male, this is the female, this is your age group from 10 to 15, from 20 to 25, all these age bands. So they know, and then the adverts are brought to you accordingly. You get it? So they are now more targeted. So these are all algorithms that with the help of AI, they are being done. And then we have the natural language processing computer. So this one also are computers or systems that learns and adapt to languages. Now we have translators that when you go to a different country and then you are not able to speak the language, you can speak English to it and then to translate it for another person to hear so that you'll be answered. The person answers and it speaks back to you. So all of these are natural translators. We have robotic kits or the robots that are able to do that automatically with the help of AI. And then we have vision. So vision robots are robots that are able to see. So they're able to know movement, where to do and what not to do. So when you go to large factories, we have robots that are able to carry one device from one end to another. So all these are vision-based robots. And with the help of AI, they're able to avoid obstacles and they know what to do. So the robot is able to determine that, okay, the space here, I have to shift it, let's say just 5 centimeters for it to fit. It's able to do all of these things. At first, there has to be an operator to do all of these things. And then we have deep learning. So deep learning, this time we are going to deep research into the universe, into deep stuffs. So we have robotic kits for that as well. Okay, so we have the types of AI. Now we have types of AI as well. So the first one is narrow AI. So narrow AI, what it does is that that's only one task. It doesn't do a lot. Like your phone, that senses your eye and then opens for you. That is only one task. When you get to a door, it scans your face and then it just opens for you. That is narrow AI. So they don't do a lot of things. They just do one thing, one intelligent thing, and that's it. They don't do a lot. Are you following? All right, sure. And then we have the general AI. So the general AI, what it does is that that's a lot of things across board. So that one is more adaptive. It learns a lot. It's able to do more complex tasks as you train it. So with general AI, you're supposed to train your model. So one thing about AI that a lot of people miss is that they always feel that AI knows everything already. That is an assumption. Normally AI, you're supposed to train your AI model. train it that when I do this, do that. When I do this, do that. This is my name. This is why I live. This and that. You are supposed to train your AI. So when you train your model, then it becomes better. So AI doesn't know automatically. You train it, and then it knows better. That is how it works. So it doesn't automatically know. Any information that is given to it, doesn't know. It searches the internet and brings you the information. So the chat GTP and other things that we have on our phones and other laptops and devices we use, you're supposed to train your AI in your field of work. Let's say you're into this. You feed your AI with data and information about what you do, what you research on other things. So that when you are searching, AI knows where exactly to go. So that it doesn't become general. So normally what happens is that when you ask the AI, it doesn't know. So it just brings you general because you have not trained your AI model. So when you're able to train your AI model, it's able to bring you the answers you need. So your chat GPT, you train it, any AI model you're using, you're supposed to train it. And then when you train it, it becomes better. I hope I'm clear. So you install ChatGPT, fine. So what you do is that at the starting, you log in with your details. That is your Google account. So any information that Google has about you, it gives to it, and then start working with it. So as and when you are going, you're also supposed to train your interest, your work, your research, what you do, and all of this. So that when you ask a question, if you're a student, what you study, all of these things. So that when you ask a question, AI knows what to tell you very quick and accurate. That is how AI works. So with general AI, that's all of these things. And then we have super intelligent AI. So this super intelligent AI is much more broader than what we have now. So this time, an AI system that is able to drive cars on its own, like Tesla and other cars that we have. AI system that can fly to outside the planet, to different planets to explore. So all of these are super intelligent AI. So now let's talk about AI versus traditional programming. So like we spoke previously, you are supposed to train your model. And then when you train your AI model, it's able to adapt, gather more data, and become better. So traditional programming, when we say traditional programming, who can help me with that? That is programming. Who can help me with what programming is? Programming languages that we have. Okay, so programming is just like coding, putting in commands for what you want a particular device to do. Are you following? So you give your command, okay, when you're going, then hit this 10 right, 10 right. So they are full of commands. You're supposed to give command at every stage. So when I hit here, what do I do? Okay, do this. When I hit here, what do I do? Do that. Come back, go straight. When you try 3 times and it's still not working, then stop, start again. All of these are commands that humans input. So that means you see a particular device that has a long code because every stage needs to be learned. So now we are looking at AI versus traditional programming. So now we can use AI to program as well. Because why? Traditional programming, rule-based, if-then logic defined by human programmers follows a predetermined sequence of instruction. So when you are programming, there's an if statement. If I get to the door, what do I do? Then you have to tell it what to do again. Open the door, and then you walk out. That is a command that you need to put in your program. So this is the if-I statement that I put in. So logic that programmers need to put in their program before these things work. But with AI, is data-driven approach where models learn patterns and relationships from historical data to make predictions on new inputs. So now it is learning. So now when you hit the door, you realize that, okay, I hit the door, I wasn't able to go. So the AI is intelligent to know that, let me open the door to be able to walk out. Or, okay, let me turn back. I'm hitting, I'm not trying. And then let me also do this. So it's able to adapt to whatever is going on. So right now, you don't need to always tell it what to do the next time it hits. Or the next time it's not able to fulfill its task. It's able to adapt and always work around. So it doesn't end. It's always learning and learning and learning and learning. That's why we say AI's database is so huge. Okay. There's a question here.
I'm Richmond. Talk of the AI. Does that mean that since I just got to know that when it gets to a bottleneck, it has to find solutions to. So does that mean that you have to give it something, an outcome or something final for it to talk of finish? Or I hope you get, if you get.
So to be clear, the question is when now it's supposed to adapt and learn. So when it hits, are you supposed to tell it what to do in the future, or it's supposed to know? How will it know by itself?
Something predetermined for you to know that you haven't reached your target. If that is clear. Okay.
So you are asking if you want to know how it predetermines the target, the final outcome.
So you have made us realize that when it gets to a bottleneck, when it finds solutions, when it hit a bottleneck, it tries to find solutions in order to get to what you expect it to do. So do you have to specify what you have to specify in it, like some sort of what it has to do? The solution. Yes, what outcome should it bring out? So that when I want to know if that is defined.
Okay, so the final output or the final outcome of a
Exactly.
particular task. Okay, so because it's an AI system and then it knows what you want to achieve. Let's say if you are opening the phone, an AI system that you're supposed to the eye to open the phone, and the phone is not opening, what does it do? So it keeps trying and trying and trying. If it doesn't, then it gives you other alternative. But another second, it's supposed to try. So if it tries, then it will tell you why it is not working. Instead that maybe it's not the right person, or maybe your eye pigment has changed or something. So it's very difficult for your eye pigment to change. So to keep trying, that's why AI is very difficult to feel. I think the phone system is only iPhone that uses the eye pigment. I don't know for the others. The others they use the face. They use your face. So sometimes when you are using facial detection, if you show the picture, the phone is able to open because it scans the face. But iPhone uses the pigments of the eye. So even if it scans the face, it will still not work. Just like the fingerprint. You get it? So if it's not able to work, it will keep trying. If it's not working, then it will tell you the reason why it is not working. So it will definitely work most of it. It will always find its way out. Then give you other alternative. Maybe you are wearing something dark that is not able to see your eye well. So to tell you to take off your dark glasses or something, and then it's able to pick. Yeah, you have to define it. Yeah, you have to define what it's supposed to accomplish. So the accomplishment is that let the phone open, isn't it? So if it's not open, that means you have to find ways and means for the phone to open. So until the phone is open, it will not rest. So it is the predefined. You have to define it. Yeah. Any other question, please? Okay. So now let's move on. So AI versus traditional programming. So aspect traditional programming, AI is prediction. So when it comes to approach, predefined rules and logic. When it comes to AI predictions, data-driven learning and pattern recognition. And then programming, human-defined rules for every scenario. Model learns from data and identify patterns on its own. So the traditional programming, that means the programmer needs to always sit behind it. That's why every time you see a code, and then every time they are always editing codes all the time, because they always have to tell the device what to do at every given point. And then now with AI based, it's able to learn from data and identify patterns on its own. So now it's able to learn that, okay, because of this, you have been using me for some time now. I've learned that this and this and that. So I'm able to know what to do the next time an issue happens. And then scalability becomes complex with many conditions. So many conditions, that means every time you have to update codes. You have to update code because every time humans always want things easier. So now I want to be able to do this. At first, you go to the ATM to withdraw money. Now I want to use my phone to withdraw money. Using mobile money, I want to transfer money from my mobile money account to my bank account to my mobile money account. I want to transfer money from the comfort of my own. So every time you have to be learning codes, but with large skills and complete data sheets. So that means it's able to do these things on its own without a lot of codes coming in. And then we have adaptability. Limited requires reprogramming. So every time, if you want it to adapt, you need to reprogram it. That is the old programming system. But with AI, it can adapt and improve with new data. So as and when you are growing, you are improving. Your AI is also growing with you. That's how it works. So AI in robotics. So perception, AI-powered sensors and computer vision enable robots to perceive and understand their environment. And then learning, machine learning algorithms allow robots to adapt and improve their performance over time. And then decision making, AI-driven reasoning and planning enable robots to make informed decisions to take appropriate actions. So all of these things are there to help the robot. I want to play just a 4-minute video for you to see how AI and robotics work together or can work together. Yeah. Make it. Sound the sound. The technical person.
Right off the bat, you're probably thinking, a cybernetic organism with living tissue over a metal endoskeleton. Yeah. Well, this is just a small part of it. Artificial intelligence, more commonly known as AI, doesn't always have to exist in a robot. Think about a self-driving car or a space probe. Both of these are robots. Yes, robots, with varying levels of AI. And then, of course, you have things like Netflix or search engines, but we'll get into that a little bit later. Okay, so the two terms robotics and artificial intelligence actually overlap. But for the most part, they're quite separate. Now, there are some variations of where they overlap, but generally, this is how it goes. Let's break this diagram down, starting outside with a simple machine like a vacuum cleaner. It has one function and one button to control it. This is classed as a machine, just straightforward simple. Now, to turn this into a robot, you could make it a little smaller, add some motors so it could drive itself around, and most importantly, upload the floor plan of your home. And then yes, it would be classed as a robot, going round the house cleaning up. But what if people kept moving furniture all the time? Or getting in the way? How could you get around that? Well, this is where the two overlap. This time, you don't need to upload the floor plan. No, instead, they have built-in sensors. This time round, it learns the floor plan. It learns that right outside the kitchen, there is a very high traffic area, and probably needs the turbo mode. It even figures out that there's a spot right under your bed that hasn't been cleaned in a very, very long time. Now that's adaptive behaviour. That's machine learning. That's an artificially intelligent robot. Okay then, what about pure AI? What does this look like? Well, pick up your phone and ask Google to make a reservation at your favourite restaurant. But wait, isn't this just ticking a few boxes on a website? A bit simple, right? Well, yeah. But levels of AI increase when you have a really deep accent, or when it actually calls up the restaurant and speaks to them for you. Don't believe me? Try it out yourself. Check out Google Duplex. But of course there are limitations. That vacuum cleaner sure is swell, but if you asked it to wash your car, it would be very confused. Probably won't do anything at all. Why? Because it hasn't been told how to do this. And if it did, it certainly does not have the robotic components to do so. You see how all of this is fitting in together now? Okay, so isn't AI just making us lazier then? Isn't this a problem? No, not at all. Sometimes we just can't do the things we want to do. Let me explain. When we communicate with our spacecraft, we use radio waves for communication, and in a vacuum, these waves travel at the speed of light, approximately 300,000 kilometers per second. Fast, I know. But actually, this poses quite a problem. The Curiosity rover was sent out to Mars in 2011. Now, because of these huge distances, it takes around 12 minutes or so to get any information from Mars to Earth, and then 12 more minutes to send the information back. Now, this time varies a little due to orbits, but can you see the problem? So if we had a basic robot, it would do as you say. You would tell it to travel over to that rock you thought was interesting, and then you would receive pictures of it. But that's just taken 12 minutes. And the photos, they're not great. You expected something else, something a little better. So you tell it to travel to another rock, and there goes another 12 minutes. But what if we told Curiosity what we were looking for? Wouldn't this make things easier? The rover could just send data back and we could analyse it accordingly. Well, this is exactly what they did in 2016. After Curiosity's initial mission, the engineers and scientists upgraded its AI system and it was able to do just this. You might be thinking that this is all code and algorithms. It's just the computer scientists working on this. And yeah, they do play a big part. But what if the Curiosity rover fell on its side? Seriously, what would you do? 35 million miles away. What, you're going to write some sort of code to flip it over? Please. So don't be disheartened that AI is coming in and doing things for us. There's a tremendous amount of work to be done still. It's a lot more than just Netflix recommendations. It's about reversing the effects of climate change, stopping tsunamis from their devastating effects, or even performing open heart surgery. AI and robotics can help with a lot of this, and we are nowhere near finished. There is so much more to do, so you best get back to work.
So as explained, AI and robotics can be combined to do a lot of things. Because of our time, we just want to do one demonstration with this machine, with AI. It's a gesture moving robot. We'll just give you the codes to work with. So I'll hand over to Nana Sasu to continue from here, to just take you through it briefly.
Hello, good morning. Okay, I just feel the theory is a little bit too much. No, we just need to jump onto the practical stuff, just assembling stuff, so we can all have fun. Okay, so this is a little humanoid. I call him JJ. Okay, it moves forward and then turns around. Okay, it spins actually from this part around, right? And so we are going to actually operate this with AI hand gestures, okay? Where we are going to train our models with hand gestures to actually move the motor part so the humanoid move, or so JJ moves, okay? But before that, with robotics, we know that robotics is a multidisciplinary field, okay? Inculcating theories from mechanical engineering, electrical engineering, and of course, from IT or computer science, right? So you don't just get to do mechanics or electronics, you also get to code as well, all right? Good. There are a little part of robots with these kits we use. I mean, I'm sure we all know a lot of robotics kits around. Okay, can you kindly give me some of the examples?
STEMID.
All right. Any more? Lego, good. Of course, it's so popular. Any more?
Mingo blocks.
Good. I'm still waiting for some two popular ones no one is talking about. Of course, Arduino. Yes. Arduino. And then which one? Raspberry Pi. Come again.
EV3.
Okay, good. So the most popular ones, I the very first ones I got to know about was the Raspberry Pi and then Arduino. Okay, but this is for educational purposes. Okay, just to learn what the kids we use, just to learn how to assemble and code. Okay, this is for educational purposes and not for actually high dev stuff, right? So it has parts, and we call this the brain. Okay, this is where the microcontroller is. It's actually inside this. So after coding, you burn via Bluetooth or via USB cable onto this, and it begins to operate. All right. So because of our time, I would have wanted us to assemble a simple car, but because of our time, it's not going to permit us to do that. So let's just stick with this. I need a volunteer. I need a volunteer. Yeah. I need a volunteer. Okay, sir. So what I'm actually going to do is we are going to train your hand gestures, or yes, with the AI model. Okay. But before that, do we actually have some idea about mechanics? How does wheels move when we are moving forward? When a car is moving forward, okay? I know there are a lot of science students here. Yeah. When a car is moving forward, the wheels move in a certain way. Let me just be simple. Clockwise, anti-clockwise. They move in a certain way to propel the car forward and backwards, left or right. Okay. Anyone with an idea? One tire moves clockwise, another tire moves anti-clockwise. Sometimes both moves anti-clockwise, sometimes both move clockwise. Okay? So I just want someone to try. Just try. We are just learning. Just try. If a car will okay.
Okay, when the car is moving forward, both tires move clockwise.
Both tires move clockwise when the tire is moving forward.
When the car is moving forward.
All right. When a car is moving forward, actually, what we see is one of the wheels move clockwise, another moves anti-clockwise. And then it's a vice versa kind of thing for when it's moving backwards. Now, for moving left, both tires go anti-clockwise. So the car moves left. And for moving right, both goes clockwise. Okay. Okay. Good. So I just want us to start with a coding. I don't know which one. All right, let's put it here. Sir, please come. All right, so I wish we could have projected this for everyone to see, but the projection is on the other computer. So this is what I was talking about. The codes are already here. We would have written it from scratch, but we don't have the luxury of time. So let's just go on with this. Okay. Okay. I would want you to just do this, okay? It's actually going to draw patterns of your palm, okay? So we can actually train your models with it. So we'd want to do this for forward movement and that for backward movement. Okay. And then let's do this to spin JJ around. All right. So when we do this, JJ spins around. And when we do this, he moves forward. When we do this, he comes back. Right? Okay. So let's start with forward movement. Please show your palm. So I am actually training his model, his palm with the AI model, just so it will be able to identify a palm. Okay, all right. So it's taking samples of his palm, how a palm looks like. And then it won't just be his palm, but a human palm. It's not biometric, so definitely. So it's taking samples of a human palm. Please, let's move on to backward movement. Please come a bit closer. Please open your palms a bit. Do this. Yes, good. So after taking the samples, we are going to train our model just to see if it's able to actually identify a palm or whatever gestures we trained it with. Okay. Okay. Please, this. Good. Let it come down. It needs to pick patterns so it could be able to identify. The lights are too much. It's from the projector. It's the projector lights. Good. All right. So now we would want to train the model. So it's actually loading the data into the AI model. And if it's unable to train it properly, it will find difficulties in recognizing or identifying those hand gestures. So it's advisable after you train any AI model or machine learning model, you actually test to see if whatever you are or whatever you trained it with actually worked. It actually took whatever data you gave it. Okay. So now let's test and see. Okay, so kindly show the hand gestures to it and let's see. Okay, so for forward movement, it's 100%. I wish I could have projected this. It's 100%, okay. Now, for backward movement, it's also 100%. For spin, so you could realize we are facing this problem. So in training it, it wasn't actually getting the patterns properly. So in the test, it's also repeating the same thing. But I think we got it right. We got it. All right. Now let's download. Okay. Forward movement, backward movement. Why are you doing this to me today?
I have changed this thing, so I'm training it again. Good.
Okay, so you are close. Then they only need a car to move so they can video when they close.
It's Bluetooth.
So a connection was established between the codes here and then the device through a Bluetooth connection. So we can use Bluetooth, we can use cable as well. All right, so because of time, if you are still interested in seeing it, we'll shift the table outside and then we'll continue from there and you can come around. So these are products here are from Avishka. Avishka is an Indian company that is into high-end robotic devices. So we have partnered with them. We are the sole distributor here in Ghana. So we have a lot of these kits from different age bands for different devices. So in case you want any robotic kits, any training or any form, we partner with schools too for collaborations. So we build robotic labs and then we do robotic functions and all of those things. So the flyers that we have, our numbers are on it. You can always reach out to us for any of these things, either robotic kits, robotic training, or a collaboration with a school for a robotic competition, any of them. So we are moving outside for the demonstrations. So if you want to see it, you can meet us outside for the demonstrations.